Notice when I do that, the 8920 will automatically change to AC level and distortion measured on the front panel audio input. In this way, you can make duplex measurements simultaneously on your transmitter and receiver. Another time saver that you can take advantage of is coupling between signal generator and the tuning frequencies. In many radio systems, the duplex radios have a fixed offset, for example, in the cellular radio band 45 megahertz. The 8920's generator and receiver can be set up to automatically track in frequency. As you change one, the other will automatically change with you. To configure this offset capability, simply go into the configuration screen, which is accessed through the front panel, Shift, Config, and position the cursor over in front of the RF offset field. By pushing the knob and turning that capability on and going in and entering in your offset, generator minus analyzer frequency, so for example in the cellular frequency band 45 megahertz, we'll key that in. I'll use the previous key to return to my duplex testing screen, and you'll notice now that the RF generator frequency and the RF tune frequency are offset by 45 megahertz. If I were to tune to the cellular band, say for example 825 megahertz in the tune frequency, notice that my RF generator frequency automatically retunes to 45 megahertz above that frequency, or 870 megahertz. You can also use this feature when using automatic tuning. The 8920 will automatically tune to the transmitter frequency and then set the generator frequency accordingly for your offset for your duplex radio. Next, let's look at the 8920 spectrum analyzer and tracking generator. The spectrum analyzer can be used to monitor the transmitted spectrum from your radio transmitter or used to monitor off-the-air signals. Let's look at an off-the-air signal as an example of the 8920 spectrum analyzer. To access the spectrum analyzer, position the cursor in front of that choice in the two screens area and press the knob. And the 8920 spectrum analyzer display will come up. Next, connect an antenna to your input port. We'll use the antenna input port, the high sensitivity antenna input port, for making our off-the-air measurement. On the spectrum analyzer display, there are 4 levels of controls. We'll show you those. The main controls, which is basic spectrum analyzer operation, the RF generator control for tracking generator operation, marker controls, and auxiliary controls. We'll start off with the main level of controls. First, we'll change the input port from the RF in to the antenna port for making an off-the-air measurement. Next, we'll key in the center frequency of a signal that we'd like to look at. In this local area, the weather channel is 162.4 megahertz. And we'll set an appropriate reference level of minus 30 dBm. Notice now that the signal is displayed on the screen, and if we turn up the 8920 speaker, we should be able to listen to the local weather broadcast. To look at a greater amount of spectrum, we can also vary the span of the spectrum analyzer. Right now it's set at 200 kilohertz. We can vary that to 5 megahertz to look at a larger piece of spectrum and look at other signals that are out there off the air. You'll notice the resolution bandwidth that we're measuring with is displayed on the upper half of the screen, and the resolution bandwidth is coupled to the span, and they change together. The narrowest resolution bandwidth is 300 hertz all the way up to 300 kilohertz for a full 1 gigahertz span on the spectrum analyzer. For more accurate characterization of signals displayed on the spectrum analyzer, the 8920 also has a marker function. Position the cursor in front of the controls field and select the marker position. You can position the cursor by selecting the position field and rotating the knob until the marker is at the peak of the signal you want to measure. In the upper right-hand corner of the CRT, there's a digital readout of the marker frequency and level. In this case, the weather channel at 162.4 megahertz and the level of minus 87 dBm. Other marker functions include marker to peak signal on the screen, marker to next peak, marker to center frequency, and marker to reference level. Now let's use the built-in tracking generator with the spectrum analyzer in the 8920 for making a swept response measurement. For this example, we'll use a radio duplexer to do our measurements. First, we'll take the antenna off of the front panel of the 8920, and we'll connect the antenna input to the duplexer up to our RF generator, and we'll route that out of the duplex output port. We'll take the output of the duplexer and put that back into our antenna input so that we complete our two-port measurement. To use the tracking generator, use the RF generator controls on the spectrum analyzer screen. You can either have a fixed CW RF generator or the tracking generator, so we'll change this to tracking. Next, we'll put in the appropriate amplitude. For the duplexer, minus 10 dBm is good. We'll confirm that the port is out of the duplex port, and our RF generator is now set up to make the swept measurement. Now we'll go up to the main level of controls and verify that the input is on the antenna input port. We'll enter the center frequency of the duplexer, in this case 451.475 megahertz. We'll set the reference level accordingly. We'll set it to the RF generator output level of minus 10 dBm. And we'll increase the span to look at the entire response bandwidth of the duplexer. In this case, 5 megahertz shows it quite nicely. You'll notice that there are 2 notches and that the duplexer is not tuned up. We can take a screwdriver and tune the cavity of the duplexer to maximize the notch response at the center frequency that we want. So by slowly tuning the cavity, I can use the on-screen response to tune the notch to maximum depth at the frequency of interest. Right about there. It's that simple to use the 8920 tracking generator and spectrum analyzer to align filters and tune duplexers. Other features available with the spectrum analyzer and tracking generator include a full offset capability, where the tracking generator and spectrum analyzer can be offset in frequency for doing IF to RF conversions or crossband repeaters, as well as normal and inverted sweep, where the spectrum analyzer and tracking generator track in different directions in frequency, one up and one down, for characterizing such things as super heterodyne receivers. In addition, using the tracking generator, you still have the same marker capabilities as with the spectrum analyzer, with readouts of frequency and level for measuring the depth of a notch and the center frequency of the notch. In this section, we'll look at the built-in oscilloscope function in the 8920. To give you an example, we'll use the radio that we used before, making transmitter measurements on the demodulated audio. We'll start in the transmitter test screen and key the radio, and then we'll go to the oscilloscope display to look at the demodulated audio. On this particular radio, you remember it has a subaudible digital squelch tone, and we're able to look at the subaudible digital squelch tone directly on the display. The main set of controls on the 8920 are vertical per division, vertical offset, and time per division. They feature real-time update as you vary the sensitivity. to both vertical per division and time per division for quickly looking at signals. You'll also notice on the lower left-hand corner of the display, the input to the AF analyzer and the input to the oscilloscope is displayed. In this case, the FM demodulation. The audio frequency analyzer input control field controls what the oscilloscope is looking at. And also notice that the display is calibrated in terms of the input that you are looking at. In our example, the level is displayed in kilohertz. If you were looking at an AM demodulated signal, it would be percent AM. And if you were looking at an audio input signal, the display would be calibrated in terms of voltage. The built-in oscilloscope also has the similar type of marker controls that the spectrum analyzer has, such as marker position, where you can vary the marker position along the signal of interest. And in the upper right-hand corner, you get a simultaneous readout of the time and level of the marker, as well as marker to positive peak plus and marker to peak minus. Other functions included in the 8920 oscilloscope include variable triggering, internal and external, auto or normal triggering, continuous or single shot, as well as one full screen's worth of pre-trigger information to capture the leading edges of any signaling bursts or transients that you might be looking at. In this section, we're going to go over the 8920 signaling encoder and decoder capabilities. In order to be brief, we'll go through all of the encoder capabilities and then go through the procedure to set up a simple decoding capability on a tone sequential paging format. To set up the encoder, go to the encoder capability. The first mode that we have available to us is function generator, which includes variable waveforms such as sine waves, square waves, ramps, and triangles. The other modes in the instrument are tone sequential paging format, DTMF, continuous digital squelch, digital paging, AMP-Syntax cellular, and NMT cellular. To change mode to tone sequential paging, the 8920 has the capability of entering in a symbol sequence, which is the pager address. For each symbol in that sequence, you have variable on times and off times, frequencies, and amplitudes. Your tone burst can be sent out single, a variable number of bursts, continuously, or manually step through one tone at a time. Built into the 8920 are a number of international tone sequential signaling standards such as CCIR, CCITT, EEA, EIA, Euro, Natel, and ZVEI. Simply choose the appropriate standard and the 8920 will automatically update its tones. The next mode that we'll look at is DTMF, or dual tone multi-frequency. Again, you have the capability to enter in your sequence or the phone number. You can vary the relative amplitudes of the high tone and low tone pairs by using the twist field. And each DTMF pair has a variable on time and off time. You can also vary the low tone frequencies and the high tone frequencies if you have a non-standard DTMF type of system. DTMF also has the same type of sending capabilities as tone sequential. The next mode we'll look at is continuous digital squelch system, where you have the capability of entering in your 3-digit hex squelch code. It has a variable data rate, as well as a variable turn-off code time. The next mode is digital paging. Both POXAG and GOLE sequential code paging formats, where you have variable data rates, variable function bits, variable pager types, such as tone-only, numeric, and alphanumeric pagers, When testing alphanumeric pagers, the 8920 also allows you to enter in ASCII characters to test the display of your pager, as well as inserting an error bit into the data stream in order to check the decoding capabilities of your pager. The final modes in the 8920 encoder are for cellular radio test. These contain the basic data input and output control